Okay, so as I said, we're starting a new topic called number patterns and recursions. So recursions are it's sort of just like, is like rules for, number formulas. Okay, so it's number patterns. We just call it recursion when we use sort of this rule language, so it doesn't matter too much. All right, so the first thing we're going to be looking at is some different things. So we'll see a sequence of numbers. So a sequence is a list of numbers in a particular order. And the numbers or items in a sequence are terms. So, for example, down here, I've got a sequence here of numbers in the pink, and the first one listed would be known as term 1, okay? And then we'd have term 2 and term 3, okay? So all the terms are called, that's what you have in a sequence, okay? And then we are generated by, a sequence could just be any number. There might not even be a pattern, or there could be a particular rule to the sequence. So in this one here, that we've got here in our example, it is a rule-based. And if you have a look, you can see that every time what's getting added to the term after to get the next one. So to go from 1 to 3, what are we doing?
Adding 2.
Yeah, we're adding 2. So you can see the rule to this finding the next term would to be add 2. So this rule is to add 2, and I could get the next one here, and then I could keep adding 2 and so on. So we see this. This is a sequence, and we can see that the rule. Okay, so we're going to be looking here. So what we want to do in this first chapter is we just want you to try to have a look and see if you can work out what the pattern is or what the rule is for the next number. So if you look here, what do we think is happening in the next one? What could be happening? So if you have a look here, what's being added to 2 to get to 8? We could say 6. Now, has the same thing happened here? Has that been add 6? Yeah, and then that. So add 6. So if we were to say the rule for this pattern equals to add 6 to the current term. So because we're up at 20, what would the next one in the sequence be? 20, what would our next one be?
26.
Yeah, 26, and then we could add another 6 and it'd be 32 and so on. So that's what we're trying to look for at the moment, okay? So as we said, they often use the letter T to indicate the term. So T1 means term 1. So down here, this would be term 1. Okay, so describe how terms are generated in the number sequence and give the next 2 terms. So let's go have a look. Who can see what's happening in this sequence? Can we see what's happening? What's the pattern here? Can anyone see what the rule is?
Every time.
Yep, good. We're adding 3 every time. So the rule is we're adding 3 to the previous term. So to get the next term, I'm going to add 3. So they want me to describe so I can describe how this sequence is made by adding 3 to the previous term. And it says give the next 2 terms. So the next one would be 17 and the next one would be 20. So nice and easy, that's all we're doing today.
So today we're going to talk about arithmetic sequences. So sequences is like a set of numbers, and arithmetic means that the rule is either you're adding or you're subtracting an amount, the same amount. So it says there, so arithmetic contains values of terms by adding or subtracting a fixed amount or the same amount, all right? So simple interest and flat rate depreciation are an example of an arithmetic sequence, and this is why we next year they combine this topic and your finance topic together. So what simple interest we saw, remember, like you might find 10% of the original, and so you might be always adding $100 on every month, okay? And because it's the same amount, it makes it an arithmetic sequence. And the same with the flat rate. We might have seen it, it's minusing $10 every year or whatever, and so it's the same amount, so it's an arithmetic. So when you add or subtract the same amount. So if you have a look here, we've got a few sequences, so we'll write them here. So here I can see that 5 is getting added. So the rule is to add 5 to the previous term, because remember they're called term 1, term 2. So if I was going to find the next one, I'd add 5 to 12, and that would be 17. All right, so who can see what's happening? What's the rule for this one? What's happening every time? What are we doing?
5.
Yeah, what about, are we adding or subtracting?
Subtracting.
Yeah,
5.
so we're subtracting 5 from the previous term. Okay, so that's the rule. Okay, so what we're going to see and this is why we sort of do this topic like this, but next year we're going to see them talking, they use this type of like symbols and wording to talk about our financial formulas. Okay, so if I was writing like a rule for this term, what I can do is I could say for this one here, I could say the rule on this. So this means when you see this tn plus 1, it means that's just a way in maths of writing how you get the next term. Okay, so you don't have to like get all worried about it. It's just a way we write how you get the next term. So how I get the next term in this example at the top here is I take the term before, and that's where I can write all the current terms, so term number whatever I'm on. So say for example T1, T2, T3, if I wanted the next term, which would be 3 plus 1, 4, I take the 3 and I add 5. So that would be how you write, and what we call that is called a recurrence rule. Okay, so when you see this n plus 1, when we write it like that, it's called a recurrence rule. So if I was doing the next one, the one underneath, if I was writing the tn plus 1, how do I get the next term? I take the last one that we've got, and I minus 5. Okay, so that's just to help you. You probably won't get too many questions on that yet, but this is where it's going to lead to, and probably best to explain it straight up, I reckon, at the start. Okay, so what we call that, the difference, the amount that's getting added or subtracted every time is called the common difference. So the fixed amount we add, and we often use the letter D to symbolize it. So up here, the common difference is -5, so I'd say D is -5. If the sequence, sorry, a bit of typo there. If the sequence is arithmetic, the common difference can be calculated by subtracting any pair of successive terms. So what successive terms means is 2 that are in a row. So say up here on our little example up there, I might use any term. So I've used the 7, I'm using this one up here, minus the previous 2, and you can see you get 5. Even if I chose 12, so 12 minus 7, it gets 5. So that's how I can find out whether a sequence is an arithmetic, by checking whether if I minus the previous term from the first one, I should get the same amount every time. Okay, so we can also write it as, so if I take term 2 and I subtract term 1, I'll get the common difference, and it doesn't matter, and we just saw before, you can take it later on in the sequence. If it's arithmetic, it'd be the same. So say for this example, I'd take a term, so I'd take 25, so this would be term 1, term 2, so 25 minus 30, so the common difference is -5, okay? So if we need to work out if it's arithmetic, that's what we can do. So you need to sort of check all of them to make sure, so you can state it. So say which one of these are following is an arithmetic sequence. So first of all, if I do 28 minus 21, that equals 7. So see there's a add 7 here. And if I do 35 minus 28, I also get 7. So I'm adding 7 to there, and this one also is an add 7. So yes, we'd say this is an arithmetic sequence. And the common difference, and D equals 7 in this case. All right, so if I look here, this one, if I do 6 minus 2, I get 4. And if I do 18 minus 6, I get 12. So they're not, this one is not, so this is not an arithmetic sequence because it has the common difference not the same. So at the moment, we're just going to say this one is not an arithmetic sequence. We'll learn a bit later what that one is. But yeah, so at the moment, we'll just say no. All right, so what I'm going to show you on the calculator, and this is pretty important because we'll do this next year as well. It becomes a big part of it. You can do your arithmetic sequences on the calculator. So I'm going to just pause the video. Okay, so that's how we do it on the calculator. We just pop in here, we pop in the first term, press enter, and it'll end up over here on your calculator. Then if you automatically just press +5, you'll see answer appears. And then if you press enter, it drops the answer into it. And then from then on, you just have to keep pressing enter, and it'll do that, add 5 to the previous one. That's the calculator's designed to that. So if sometimes you get asked to graph your sequence, so obviously if you have to graph it, so say for our example here, our first term might have been here on 2, so we'll say 2, and then your next one was on 7, and so on. Okay, so this would be this is term 1, term 2, term 3, and then you put what the actual value is. So when you have an arithmetic sequence, it's always a straight line, and we would have seen that too on simple interest. If you remember simple interest over time, we just saw that if we have the value, you just saw it goes up on a straight line. So an arithmetic sequence if you graph it, will be a straight line because you're always adding the same amount. All right, so let's have a look at this question where they ask us the graphs. The sequence 4, 7, and 10 is an arithmetic sequence, and the common difference is 3. So we could see that if we did 7 minus 4, so T2 minus T1, we got 3. Okay, construct a table. So if I went to keep continuing this would be term 4, 5, and 6. And obviously I'm just going to add 3. So this one's easy because we're just adding 3. So 13, 16, 19. Okay, when they say draw a graph, you don't have to, don't be spending hours. All you do is just quickly draw, you want to be drawing these 2 lines ruled up here, and draw Tn, so that's the value of the term. And you can just even put, you probably can just do the 1. So term 1 we know was 4, so you might put 4. And if they told you to go up to term 6, so draw, it's a straight line up, so just draw a straight line and then say that that is 19, okay? That's all you have to do. No big stress there, or even if you just write 6, 19, 1, 4, it doesn't matter. You just make sure it's a straight line, and you're remembering that this is the term number and the value of the term. All right, so